Hello, Lays and Lie here. Today we are going to be doing step assignment number 10. So I've decided that we are going to do many assignments today. Hopefully we will be getting through at least 10 and 11. Now funny thing is I haven't actually finished 8 and 9. I don't think I streamed those. But unfortunately, 8, I have done around half of it, excluding the step question, and 9, I've done all of it except the last bit, which was Euclid's proof that an isosceles triangle has two equal angles. So that's quite annoying that we haven't completed those quite yet. I'll see if I can finish them at some point today. And there's also a bunch of papers that I haven't marked yet. I did Jacqueline Tyler paper, set A. Let's see, set A paper 1, and I came away with a score that I'm not particularly pleased about. So I'm glad that I didn't stream it. And paper 2 I haven't done yet though, and that's the logic and proof bit, which usually I get similar marks on, but I did mess up on one of the previous papers and get a lot lower mark. So I don't know. It'll probably be the same, but we'll have to see. It also might have something to do with just general exhaustion because well, you're fresh for paper 1, you're not fresh for paper 2. And so it is. So, without further ado, assignment 10, sorry, warm up. So, we've got a triangle. It is perpendicular. Lovely. So we have our triangle APCB, where this is defined as alpha, this is defined as beta, this is 1. Show using the sine rule that number of numbers add together to be number. Omoshiroi. Okay, so the first thing, I guess, we can define sine alpha plus beta to be below some AC. Over AC to be equal to the others, which is, let's see. So this is 90 minus beta, which means this is cosine beta minus AB. And then we have also BC cosine alpha for the same reason. And now what we need to do is we need to find let's see. So what is sine alpha equals to? Because we already know actually, so we'll rewrite the cosine thing. We already know that this is in the correct form. So this bit is in the correct form, this bit is in the correct form. So all we need to do is get the values for AC and AB. And we can do that by looking at sine alpha first. So sine alpha is equal to AC divided by 1. Oh, sorry, not divided by 1, divided by AP. Is that correct? AB. No, sorry, this is AB, isn't it? Okay, AB and AP. Yes, that's the sound, right? What if we write cosine instead? Because cosine does show up in one of them. So, for cosine, it's 1 and AB. Oh, sorry, no, it's AB here and 1, which means that AB is therefore easily cosine alpha. So we can replace this bit. Actually, we won't. We'll keep that there. But we will consider this one of our mysteries solved, and now we need to figure out what AC actually is. So AC is equals to two numbers adding each other. So we need to figure out what AP is, which I trust we can relate to 10 somehow. Yes, we can. So Let's write tan alpha. So if we can figure out AP and PC, we can figure out AC. You can use tan to figure out AP. So that's the opposite AP over 1. Yes. And the same thing applies for tan beta. That means AP equals and PC equals tan beta. And that means, lovely enough, we've obtained this result. If I haven't made any mistakes at the very least, this should be the answer. But this is inconvenient for us. This does us no good. Because it doesn't look like your answer, even if it might be. Make sure we haven't done any mistakes. Oh wait, I see what I've done. This is wrong. Or some of it is wrong at least. This isn't divided by anything because the opposite is on top. My bad. Actually, we have this, and thus we can simply substitute our final result. Now the next step is to continue to do some writing. Let's see. So we can pretty clearly say that this is cosine alpha, and since this is divided, this is used. Okay, how do you say it? This is to the power of -1, and then to the power of -1 again. So this becomes simply cosine alpha. Then we can multiply this entire mess by tan alpha, course tan beta equals sine. And since this, as we all know, is sine alpha over sine beta. Oh no, so cosine alpha. That's what tan equals. So cosine alpha cancels each other out. Same thing basically applies in order for us to get sine beta and cosine alpha here. And that is result, QED, whatever you say. And then they've asked us to obtain some more results. They've asked us to obtain results for sine minus sine alpha minus beta, which should be easy to figure out. Because we know about even and odd functions. So cosine x is equals to cosine negative x, which means that this simply computes itself. This simply computes the original. However, sine is an odd function, and odd functions, any odd function, negative sine x equals directly to sine negative x. So in that way, this becomes negative. So therefore, we have this result. So that means it should also be trivial to figure out cosine alpha minus beta once we figure that out. But before that, we need to figure out alpha plus beta for cosine. Now, I don't quite recall how to do this. This is pretty standard GCSE fare, sorry, A-level fare. So any high schooler should have done this. It's just that actually remembering the proof and being able to recite it is another matter. Let's see, we can be lazy about it and do this. So now that we've done that, we sub in same bits, sine 90, cosine, sorry, so in order for us to be able to parse this, we need alpha and beta to be separate. So let's consider this as one chunk, and this is the other chunk. So sine 90 minus alpha, cosine negative beta. And then you also have plus, or is it plus? Ah, no, it's not. It's negative, isn't it? Minus. Actually, if it's minus, then we don't need the negative sign there. Minus. Let's see. Sine. Beta again. Cosine. And you minus alpha. So now we have sine, beta, cosine. Oops, sorry. Sine alpha minus cosine alpha, cosine beta. And that is our result. So next up is simply plug it in once more. And obtain easily the result. Again, with the odd and even functions, that cosine alpha, cosine beta plus sine beta sine alpha is our answer. Great. So now let's find sine 75. And 75, we can properly reduce this to 45 plus 30. And 15, we can properly make into 45 minus 30, which means that we can just plug it in again. Now, this is not the most interesting. I appreciate the not the most interesting of lessons, but I suppose it is how it is. And to be honest, after I achieved that remarkably bad result on the JZ Mass mock, which I did yesterday, I don't have any right to complain anymore. I've just got to shut up and deal with it. Now we have this. Should be our answer. I don't see any way you can make it simpler, so yeah. And now we continue with this, which is essentially the same thing, but minus. Now by expressing cosine 3a as cosine 2a plus a, find an expression for cosine 3a in terms of cosine a. Once again, a bit of simple plugin. Plug it in. Plug it in. Minus sine a. Okay, so now it's sine a cosine a plus, you guessed it, sine A, cosine A. Oh wait, these are our identities. Huh. Yeah, these are our identities. Oops, I should have just recited them. Oh well, doesn't matter now. 2 cosine. And then you have cosine sine, which you can render into the wonderful sorry, how did you do this again? Wait. I'm just making sure I don't make any silly mistakes here. So 1 cosine 2. Yeah, okay, so then this becomes 2 cosine 2a minus 1 times cosine a. Moving all of this because we don't need it anymore. And then finally we have cubed cosine a plus cubed, which all adds together to this lovely result. This done. Jesus, what a mess. Okay, so now let's go do 2 at break speed. Write down the prime factors of 120. So we know that it's 2, 3, yeah, 3, and then 5. Which, yeah, that sounds right. Now we've got to find values. That renders this into 2 times this, which is 2 to the power 5. Now they've asked us to show that if x is an integer and a is a positive integer, then x to the power of a 1 minus 1 over x is an integer. Shouldn't be too hard. So we've got x minus 1 is a reduces into x minus a times x minus 1. Given that x is larger than 1. Wait, x is in z is a set of integers, and a is above 0 and also in the set of integers. That means a minus 1 must be bigger or equal to 0. So x must also be an integer. We can remove the must there. This a bit closer for clarities. And then, yeah, also since x minus 1, yeah, x minus 1 is an integer. So yeah, let's move on to triple I. Write these two funky little numbers. So we know that there is 100. 100 is definitely a factor, so we can just reduce that to 2 to the power of 2 and 5 to the power of 5, 5 to the power of 2. Then we've got 396, so 3 is definitely a prime factor, so it reduces into 132. And 3 is actually a double factor, so it's 43. Is it? Depends, alright? No, it's 44. It's 44. So 44 means that 2 is a factor 4 times, and then the final one is 11. So cleaning that up, turns into this. Then we apply the same process for you. We you're divisible by 3, so let's see how we divisible by 3. Let's see. So it's rather an annoying, complicated, involved process. Let's see. So it's 1,800 minus whatever this is. This is 36 sounds about right, 36. So then this is equals to 1764. So then we can add a 3 here. We can add properly a 2. We could just do it, divide by 2 into 80, 85. So this becomes here. Divide by 2 again. Add two twos. Now this is definitely not divisible by 2 anymore. Won't ever be. And it's also much tougher not. So, let's test, right? It's 7. Oh, never mind. So it's 7. Yeah. This is divisible by 7, so that's 50. Sorry, 60, 63. 63, which we know is divisible by 7 also, into 9. So there's two more times that 3 appears, and 7 appears twice. And should be our final answer. Lovely dovely. So, hence find the highest common factor. So this is one of those tricky ones that requires you to recall a technique that you've basically not used since high school, since primary school. I think it's 2 to the power of 3 times 5 times 3 to the power of 2, since these are all common to the two of them. So let's leave it at that. If and only if mean very different things. For example, the statement a squared equals b squared if a equals b is true. But the statement a squared equals b squared only if a equals b is not true. Because a squared equals b squared is also true when a equals negative b. And they've asked us to start using the symbol implies, which is just an arrow. Wonderful. So, where's my pen going? Neither is this. So, so AB is even if both A and B are even. Lovely, good for you. Okay, so let's look at this. First one is A. AB is even if both A and B are even. Which is basically saying if both A and B are even, then AB is even. And there is basically no case which is false. So both A and B even does equals AB is even. True. B. Okay, so this one, I reversed the direction. point like this, and since only if reverses direction again, so it should point like this if we were to rearrange it in the correct structure. So AB is even, A and B are even. Oh fuck. Okay, I just completely fucked up the writing there. Are even. There you go. False. Very clearly false because if A is odd and B is even, then it becomes even. So yeah, AB is even does not imply A and B are both even. Now A equals B if A equals B. Oh, sorry, they've asked us to express it by crossing this out. So we'll cross it out, even though crossing out usually means for me just it doesn't it's not real, but I guess he'll follow the procedure. This is false, isn't it? Definitely. So this is false. This is true. This is true. And the other way around is also true. This just isn't that interesting. Come on, where are like the fun questions? This is boring. Come on. Oh, yeah, there we go. So, oh no, this is IFF. So, cool, I guess. Oh, so this is just true false. Oh, we have to rewrite it if it's true. An even number is prime if it is 2. If and only if it's 2. Yeah. An odd number is prime if it's true. If it's 3. False. X equals 3 if x squared minus 9 equals 0. No, because of -3. Triangle with sides length A, B, and C is right angled if A squared plus B squared equals C squared. I mean, you've not exactly given them in any order, so no. Like, it could be that C squared plus B squared equals A squared, right? Or you can actually consider it true. Yeah, no, I think you could consider it true. Because you don't specify which one is that way, so you can arrange it any way you want. Yeah, okay. So triline is scalene if no two angles are the same. Hmm. Sure, we'll consider it true. If a number is 3, if an odd number is 3, it is prime, which is a shocking but ultimately uncontroversial statement. And if x equals 3, then x squared That's 9 equals 0. Yay, we've learned how logic works. Now the step question. Let's go. So, if we're any positive integer and the function f of n is defined by whoop, 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 where p and then a p1, p2, and all the way up to pk are only prime numbers which are factors of n. Makes sense. So let's look at 1a. Oh, sorry, IA. We can evaluate. It's 2 to the power, 2 squared times 3 is 12. So that means that it's 12. 1 minus this. 1 minus this. Turns out to be this. And this. What was the example they used before? Hmm. Hmm. Okay. Well, let's ignore that. Let's see. Yeah, so this is just equals to 4, 2. So yeah, this is 4. And then our lovely, oh, no, not 80. It's 12. And we've got 180. Oh, wait, what's 180 again? 180's prime factors are, oop, 3 to the power of 2, 3 to the power of 2, and 5. So you have got something looking not dissimilar to this. Yeah, this is crosses out. Comes 2 and 3. Means that it is now 16 times 3, so it's 48. Right, so now let's get to the fun part, which is proving that f of n is an integer for all n. Okay, so discussion requires a formal proof, which we can see. Let's see. So let's rewrite n. I guess that's the first thing, which is that p1 times some, I don't know, arbitrary. What's like a nice number we can describe it with? A, sure. A, B, C, D. A, Z. Sure, whatever. Actually, no, that's not good, is it? Okay, no, A1, A2, A3, A4, AK. Fine, that's good and proper syntax. Now what? Now let's write this times our big ugly mess. We're on a 0, A. Good. So, this isn't particularly interesting. We're just drawing up some, nice little words. So, now we just write the same thing as before. So now we have P1 A minus 1, P2 A2 minus 1, up until PK A minus K minus 1. And since for R minus 1, or AN must be at least 1. So AN minus 1 is larger or equal to 0. Therefore, this must be bigger or equal to 1. No, that's not what we want to, that's not what we want to figure out. We want to figure out that we want to figure out. Okay, no. So we can write the truth. I don't know if we have to prove it or not, that A to the power of K. Okay, no. So like n to the power of some K, where n and K are both integers, is an integer 2. No. So we write this. N to the power of K is an integer where nk are integers and nk are bigger. Actually, just k is bigger than 0, bigger or equal to 0. So therefore, this P1 must be an integer. All of them must be integers. And P1 minus 1, also an integer. All terms multiplying together are integers. We did it! I don't think this is that formal of a proof, but I mean, it makes sense. It's not exactly hard to figure out that, oh, turns out like these prime factors all have to be at least 1 for them to even exist in this chain in the first place. So they naturally cancel out. I don't think it's that hard to figure out. All right, so now they asked us to do a bunch of proving and disproving. So f of m, f of n equals f of n and n, which is equal to this, all the way this. Oh my god, this is gonna be annoying, isn't it? Okay, so, oh my days. You can't use P, can you? Well, let's use fucking what's some Q, Q1, B1, Q2, B2, all the way up to B. No, Q. It can't be J. It's I don't know. I and J iterators. We can't exactly use those. K is just arbitrary constant. It's lovely, lovely for using. C. It's gonna suck if there's three numbers. Whatever. So, this is N. Lovely. So now one side, left hand side, is this, so on until this, 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 divided by this, one minus, oh, isn't this fun? This, and then it's Q1 minus 1, Q1, Q2, this is QK, no, it's QC. Ah! QC minus 1, QC. Done. Okay, that's the left hand side. Right hand side. They're not the same. Because if P. Okay, really, blood? Okay, no, I'm not erasing all that. It can stay there for all I care. Right. So, counterexample is trivial. If you have two, you got two, four. These aren't equivalent. Is two, one minus two, two, one minus half, sorry. And four, one minus half equals two. This equals one. Ta-da! Counterexample. Yay! Right. Sure. Let's see. Oh, oh, A. B. If they're distinct prime numbers. Okay, I think that's true. So, if Q distinct primes, then f of p is just equals to p. Huh? 1 minus, oh, sorry, p minus 1p. So we can write basically the same thing for the entire expression. Now we have f equals pq, which is this, minus this. Yeah, okay, so let's look at the left-hand side, right? So this is left-hand side, this is right-hand side. Let's look at the left-hand side, which does say, how do you do this? So P, okay, wait. So if you multiply this side by Q, that becomes QP, and you're timesing both sides. What am I doing? That's the left-hand side. Ignoring all that other shit. Which is this minus P minus Q is 1, 2P. So once again, decidedly non-equal. Okay. Okay, let's try and find a counterexample for the next one. Then we can try and figure out. Let's try and find a counterexample for them first before we try and prove them, just so we can stop wasting our own time. Let's try this out. Counterexample. So we know f equals 2, just equals 1. f3, however, did this. Now f6. Wait, what? What? Oh, son of a bitch. Okay, wait. Okay, wait. So no. So maybe I just chose the wrong counterexample. What's this again? So this has to be equal to this. Oh, it's not G. My bad. Wrote G by accident. So that means we need some kind of circumstance where these two are not equal to each other. Okay. Yeah. So for the left hand side and the right hand side to equal each other, this has to be true. And this is evidently not true for 2 and 3. So hmm, difficult. Difficult. Okay, I've probably made an error. A blunder. Classique. I blunderous. I don't want to just blindly throw myself into another counterexample. But at the same time, I feel like it, so let's do it. Okay, let's choose F. F equals what would be nice, huh? F equals 3. F3 and F5. So we know that one of them equals 2. The other one equals 4. The other one is 15. Oh, I'll be damned, it's correct. I'll genuinely be damned. Okay, no. So something's gone wrong with here, right? Oh, I see what I've done. I'm a complete molly. That's what I've done. Started at birth. Right, this. These two are very clearly equivalent. Equivalent. Idiot. Idiot. Well, I just messed that up. Okay, so all of these counterexamples are wrong then. Yeah, okay, all of this can just go. Bye. Yeah, there you go. Okay, well that was a stupid waste of my own time, and now let's look at C. F of P. So if F of P e sorry, F equals this, then that implies that F and Q are distinct primes. This is going to be annoying. Now it's true, but it's going to be a pain in the ass to prove, so I'm going to go on to the next question. Yay, let's look at positive integer m and a prime number p. Fuck, no, that looks hard. Okay, no. So, let's probably just continue with this. Not sure, not sure. Hmm, where's the entry point? I guess we could do like assume p and q are not distinct primes. Horrible. Horrible. Now we get to copy all of this mess over. No, we don't, because they use P. Ah, fuck. Okay, so they use P and Q again, so that means we don't get to. But that means we get to use M and N, which are much more pleasant anyways. M and N. M and M, N, M, N, M, N, M, 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 fuck. Where have we gone? Oh, there you go. Okay, so we assume they are not distinct. Does this work? Oh, okay. So P equals M1, A1, M, just K, A. K, I don't care. N1, A, the B1, N, K, dot, 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 B, K equals Q. Now this equals to, wait, can we write this as like a sigma sum? We could, couldn't we? This is some N. Ooh, this is nice. Okay, so this is like a fun game, isn't it? So this is Ricardas I. This is A and this is also I. This is 0. No, it's not. No, no, it's 1. Starts with 1 now. That's what I say. So, yeah, okay. Okay, we like it. We like it. This can't be N, though. It can't be N. It has to be some arbitrary number. Welcome back, B. And this is C now. So this is also I, since that can be the case. This is N, and this is I. I'm having more fun drawing up the numbers, like just random arbitrary numbers that, oh, fuck, no, this is reused. Okay. So, wow. So this is D and this is C. Sure, good enough. Oh, it doesn't even fucking matter, because then we have to draw like 1 minus 1. Ah, shit. And also, it's impossible it's impossible to manipulate, anyways. Fuck. Oh, this is such a pain. Hmm. Okay, you know what? We're taking the easy route. Shit. Easy route. Attempt number 1. Copy. And I gotta tap on you. Oh. You good? Yeah, computer's broken. computer, computer, calculate, calculate, computer, calculate, computer. Fucking A. Right. Son of a bitch. I don't care. I'm writing them all like this. I don't even care. I'm writing enormously fast. You know what? You want to see how fast I can write? I can write really fast. Come on, look at this. Look at this. I can't even see how fast I'm writing. That's how fast I'm writing. I can't even see how fast I'm writing. What's A? I don't know. I don't care. Done. Okay. Wow, that's quick. Okay. So F P Q equals fuck. F1, a bunch of stuff. These cancel out. Good enough. And then we have shit. Then we have hmm. This doesn't work, does it? I can't believe I spent that long trying to figure out how to write down working, and then only to realize the working doesn't actually work. Because if you just copy it down, then these two obviously equal each other. So then our proof of contradiction doesn't contradict, and so that doesn't work. But wait, what if we just counterexample it? Oh fuck. What if this is actually false? I thought it was true. I assumed it was true, but what if we could counterexample it? Let me think about it. Okay, I have an inkling. I have an inkling. So, what about F4? F4 equals F8. So, F4 is 4 divided by 2, which is. So, F4 equals 2, so that's 2 times 2. 8, 1 half. Yep, okay, counterexample. Da da! Fuck. God, what an irritating question. Okay. So, moving on. Find a positive m and a prime number p such that f m p equals all of that. So, I think we would be benefited by finding out what this is as a prime. But what this one's prime factors are. So let's go through the list, right? The classic list. 7. 7 is out. It could be free. Eh, Um, no, it's not free. It's not free. It's not 9, obviously. It's not. Could it be 11? It is 11. Okay, so our answer is 11. Cool. It would be nice if I memorized the. It would be nice if I memorized the divisibility rules so that I could apply them at a regular rate. However, I have neglected to do so, and thus I shall pay the consequences. Right. So, 11. How do you divide this by 11? So you got 1, you got 3, you got 3 again, you got 1. Okay, so, wow, that's late. Is it just 11 again? I think this is just 11 again, right? 3. Yeah, it's just 11 again. Okay, so, huh. Okay, so you divide it by, wait, shit, how do you do this? So you divide it by, to get this. Am I right? Redundant question, I always am. So that's 11 to the power 4. Right, great. Good for you. Now we need to figure out a prime number and a prime number p that creates us into this. Difficult. Now my thinking is that 10 could be here. This would mean this would have to be 11, right? So you could have one part of it be like this. That's how you get the 10. Oh, and then you could just have it be 11 here. Make it 11 to the power 5. Oh, wait, that's it. Oh, is that it? Oh, fuck, the answer is 11 to the power 5. Okay, that was easy. Ah, oh, that's crazy. Okay. Well, the function defined in this question is called the Euler, the oiled up totent function. The value of f of n is exactly equal to the number of integers less than or equal to n, which are coprime to n, i.e., have no prime factors in common with n. Huh, that's crazy. Okay, that's crazy. Okay, let's go do the warm down then. The following questions are taken from the first examination set by the University of Cambridge Local Examinations Syndicate. Wow, the syndicate. What's our time looking like? I know I spent forever trying to figure out a stupid fucking not a counterexample, but a proof. Why's my bitrate at 0? What does that mean? Why is it so low quality? Maybe that's just made me dumb. Okay, whatever. Back to the stream. So let's figure this out in the 10 minutes. Then we can mark our answers and go on with a lovely day. At least I'll take a little break. And I'll be back on um I'll be back on 11. Yeah. So workmen can perform a certain labor in a week if they work 11 hours a day for 6 days. How many hours a day must they work to perform the same time if they take half of Saturday as a holiday, but do a 12 more work per hour? On another paper, candidates were asked to draw from memory a wheelbarrow turned upside down. They were allowed an hour to do so. You can do this if you want. Wait, fuck. Circle goes here. Circle goes here. Here. There, we've drawn Picture of your mother. I.e. a wheelbarrow. I spell barrel. There you go. Wheelbarrow. Lovely. Pretty sure this qualifies me with Cambridge now. Anyways, let's continue. The workmen can perform a certain hour, a labor in a week if they work 11 hours. So let's say that they work some 11 hours, so 66 hours total, for some constant K work rate to achieve this. Now let's say K is a 12th better, which is this. But gas shop horror, they're being lazy because they're peasants and they only do let's see, they take half of Saturday as a holiday, as in they do 6.5. Yeah, so that's our number. Oh wait, no, they're asking how many hours they do in a day. Okay, wait. Oh, okay, so let's see. It's 11 times 6. So now we have some I. Now this I is how many hours a day they must work. Now they only have this many days. So now these two equal each other. Take the K out. 5.5, that can become 11 divided by 2. These two can cancel each other out. Now we have this, which I believe is just this, right? So how many hours a day are they working? Around 10ish. Yeah, around 10ish. Oh no, actually 11ish. Okay, cool, good for you. Okay, so I'm just gonna leave it like that. The difference between two numbers is 3. A minus 3 equals 3. The difference of the cubes is 200 and some massive number. Find the numbers, please. Fuck, okay. This promises to be annoying. Hmm, definitely annoying. Maybe there's like some stupid way to expand this that no one fucking uses because it's irrelevant. Irrelevant to the world. What if you do this? That's a okay. Okay, we're doing this now, I guess. That's this, 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 and this. Except I did that wrong because of this. And also this is wrong. So yeah. Now we can nicely take AB out to get this. Hmm. First of all, I'm pretty sure I've done some kind of arithmetic error. I have. Yeah, I've spotted it. This is in fact a plus. This is a plus. Plus this is this. So now by doing all that, notably enough, this doesn't actually mean anything because it doesn't equal anything. It was just a bit of maths that I did for fun. Now let's get on with actually solving the fucking question. Way! Oh, Lord Jesus. I'm agnostic. I don't know why I did that. Now we can put bounds on it? I don't know. Man, am I too stupid to do a junior question paper? This was meant to be for some guy who was like 15, starving, fed on literal rats. It was like 1959. They couldn't even vote yet. I mean, of course they couldn't vote. They couldn't vote now, but they couldn't vote even if they were an adult because the whatchamacallit act hadn't been the Reform Act hadn't been passed yet. This is a voteless, disenfranchised idiot of a fucking peasant, and I'm struggling with the same question that they were. Does not bode well for me or my academic future. Does it? Let's try dividing it. I don't know. The two. This is squares. Fuck no, minus 11 maybe 91. Great. So now we have this. Honestly, would I just be better off if I just plugged in some random fucking numbers? Yeah, most likely. Yeah, to be honest, I have like a vague idea what goes here. So let's see. 25 times 25 is 605. Then we have what? 28 times 28. Sure. Go with that. Which is 560 plus 8 times 28. What's that again? Second is I'm not stupid. How do you add? How do you add? Wonderful question. This is like 420. Yeah, okay, that's right. So now you got this. Oh my god, did I just hit the answer? No, okay. No, no, I'm still a ways off. So no, no. The numbers have to be bigger then. You know what? No, this is a stupid waste of time. I'm stronger than this. I believe in myself. I can probably do this. Come on. At least I know the other questions can't be that bad. So, oh boy, I didn't expect this to take this long. Right. Wait, what if you just subbed it in? I swear to God, I might be dumb. What if you literally just did fucking this? The most obvious thing you could do ever. I swear to God, this gets me the answer. I'm gonna crash out. I mean, it'll make a pretty ugly quadratic, but it's a quadratic. I mean, we can solve those. I also thought I could do questions from fucking 200 years ago before this, but you should look at that. Some things are just destined to be false. What was I doing? Right. This is less than ideal. Let's see. This. Forget that for now. Ignore the b squared. Took longer for me to say ignore the b squared than it took to actually do b squared and then cancel it. What are we doing? 6b. Oh, wait, no, I forgot this. Right. 18b, 9b, and you get 27 and minus 27. And it equals 0. So now it is 27b minus 2, 6. Yep. So now we got our answers. This is all divisible by 3. Fuck me. What's the way to do it? Right. Okay, this is annoying. Now all we need to do is compute 9. It's just this. So this is 4, this is 11. This is negative. Let's try that. 11. Done. Okay. So B is 4. A is 7. It's killed! What am I doing? Rage bait. Ah, okay. Fun. How did they even like teach people back then? Like I know UC. I went to the UCL lecture for the 200th anniversary, so I know kind of how they taught people. Like they taught children, and only like white people could be taught, which is expected. But how did they teach people from like the ages of 6? And unless you were noble, unless you were noble, how would you get taught? Like 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 even like basic algebra. Where would they learn that? Maybe they just started with nothing. Maybe Cambridge was only for rich people who could afford tutors. That makes sense. Anyways, let's move on. So, some disgusting numbers. Really? That's it? Son of a fucking bitch. Sure, is this a nice answer? This doesn't look very nice. Nope, does not look nice. Where have I gone wrong? Where have we sinned? Oh, I mean, it looks alright to me. Like, what do we go wrong? Guess maybe you could do this. Guess you could do this. Which case it turns into 3 divided by 3, 3. This. I guess you could. Yeah, I mean, that looks kind of nice, I guess. I wouldn't call it nice, but I mean, I don't know, you do you. Sure, good enough. Okay, and that's this miserable fucking assignment over. It's not that miserable. There's always those with geometry in it. Geometry, anything with geometry is 10 times worse than anything without geometry. But it is time to look at the answers. That's the first time that we are going to be looking at the answers on stream. This is not very often when we do this. And the reason is because I was lazy and I wanted to end the stream because I was really tired. But now we are very experienced. We have done lots of these streams and we know, well, I know that more often than not, I get the correct answer because I'm very intelligent. That implies sometimes I get the wrong answer, which is unfortunate for the viewers. So let's go solve it. Go solve this problem. First of all, let's close OneNote and then reopen it because otherwise I'm not going to be able to do anything. I swear, like other streamers, like doing 10-hour marathon streams, and then I have to restart my fucking OneNote. OneNote, by the way, made by Microsoft, well, not biggest company, but like one of the biggest companies on the surface of the planet. And then I have to restart it every fucking like 30 minutes. What is this? What is this? I mean, it could be that my computer is a piece of shit, but also I bought it like a year ago. My warranty expires in like 3 days. Actually, I think it already expired. But the point is, it's a good piece of technology. I paid good money for it. Now, the fact that it is a laptop is quite inconvenient. It means that I could have probably made like a PC that was like 10 times better for the same price. But at the same time, I mean, come on, like it's technology. Like this is literally the pinnacle of technology. Show this to someone from what was it, 1858, and their eyes would explode. Like, show this to Ava Lovelace and her fucking harmonic machine. Her brain exploded. And yet, I have to restart this piece of shit. I mean, not every half an hour. I didn't even restart the stream until just now, but still. Anyways, off of the rant, on with the do. I can't be bothered to verify this. So they prove sign pretty quickly. Do they? So they magic the 10 like the first bit really quickly, and then they essentially do the same thing. Do be careful with brackets. Very nice of you to remind us. And well, I know for a damn fact that I got the addition formulas right. And you can also derive tan very plainly. But I forgot how to do that, so let's move on. Now I kind of remember, but it take like 10 minutes extra to rip it out of my brain. So we're gonna ignore it. No, fuck. Boo. Boo. Not good. Or at least that's what I say if I gave a shit, but no, I don't. So, I actually no, it's just right. It's right. Oh yeah, I forgot. New pen, right? Ticky pen, ticky, ticky. We love Mr. Ticky, ticky. We just say it's right. Don't care about the truth. Rage bait successful. Why is this for? Because he can't do much. Okay, wow. We'll give it half. We'll give it half. I was close. I was close. That's what I'll say, by the way, when I get a 4 in TMUA. I was close. If I had just picked the correct answers, I would have gotten the correct answers, and therefore I would have gotten a good mark. So yeah, basically the same thing, right? Basically the same thing. I mean, maybe I missed like one or two bits, but basically the same thing. Though I did write something wrong. Oh no, I just expanded it. No, no, it's fine. It's fine. It doesn't matter. It doesn't even matter. Yeah, I'm not reading all that. True. False. False, true, true, true. True. Ah, it's false, false, false. False, false. Wrong, false. Right. It's certainly the case that triangles right angled if. Damn. I knew it. I called it. I called it. Step 448. Oh, let's go check our lovely. Oh, fuck. Hmm. Really? Really, blood? There's nothing wrong with the negative solutions. I forgot about I forgot about It's fine. Why did I assume it was gonna be? Why did I assume it was gonna be negative? I'm a dumbass. It's correct. Right. Okay. What wrong? What went wrong here? One way. One way. Right. It's cute. Okay. Well, so we've learned a lesson today. Turns out those guys back then were on fucking crack. They probably were, but like those guys were goaded at the job. They did the stuff, you know. I was making fun of those guys from like in 1858, but damn, they're actually not terrible. I think. Okay, right. Let's just find the ones where simple counterexamples can do it. Oh, okay. So this I kind of got right. I forgot to prove that Q and P are not distinct. It's not true. So I guess I'll take a little bit of a mark off for that. But counterexamples, I think are valid. So those go through, and then you got this big ugly proof. Yeah, so basically you're just saying repeatedly and repeatedly this part is an integer, therefore this part is an integer, therefore this part is an integer. So let's go fuck this question up again. Yay! Oh, that's just a lot of algebra, isn't it? No, I'm not doing all that. Right. So that's this problem. This thing over. Fucked up a bit of the algebra. Most of the proof stuff was alright, but then of course I wasted too much time on it. So yeah. Oopsie doopsie. I guess this kind of stuff does show up on paper too a bit, so oopsie doopsie again. My goal is to complete 10, 11, and 12 today, so I guess we will be seeing each other